Hello, welcome to Accounting Hub. I'm Professor George Scarping, PhD in Accounting, and our topic today is exponential distribution on Tableau. So first of all, what is the exponential distribution? Suppose that some event occurs as a Poisson process. That is, the number of times an event occurs is a Poisson random variable. What is this Poisson process? It is the Poisson distribution. And by the way, we have a video about Poisson distribution. The video is in our video description. Okay? So, models the number of occurrences in some unit of measure, often time or distance. So, if we are anything based on time, Poisson is the one. There is no limit on the number of occurrence, and the average number of occurrence per unit is a constant, then denoted as lambda, and expected value is equal the variance. But let x be the random variable of the interval between successive occurrence of the event. The interval can be some unit of time or space. Time, hours, or space, miles or kilometers or whatever. Then x is described by the exponential distribution with parameter lambda, which is the mean number of events that can occur per given interval. So we have the formulas here, and if you are working with Excel to calculate it, we need the Excel file. We need the lambda, and mean is equal to 1 divided by lambda, or variance is 1 divided by lambda. So lambda is 1 divided by mean. And the exponential distribution is just like that if we are talking about the exact number, okay, not the cumulative. The cumulative is just like any other distribution. So let's come here. So here our Excel file, it's also free, and the link to download is in our video description. So the mean time to failure of a critical engine component A is 5,000 hours, and of component B is 8,000 hours. Let's see the distribution charts. So here we have the calculated, and we have the formula to do it on Excel much easier than Tableau. Tableau is very good for graphing, not for calc. Calc, you need some programming and so on. And what we need on Tableau, so here we have one column for each component. On Tableau, we don't need a lot of columns here. We need only 4 columns. Whoa, that is too small. Component, if we are talking about component A and component B, the number of hours and the function, the exactly number, so the probability that the component A will break at the exactly 1,000 hours is, if we go on percentage here, 0.01 or 0.02%. Or the cumulative probability to break until 1,000 hours, 18%. So until 5,000 hours, 83%, and so on. And the component B is over here. So component A, that is 5,000 hours, component B, 8,000. So let's rename it. Component A. So component A, 5K. And here, component B, 8K. Now, they are just like your file. And then we know here which component we are talking about. Or better, component 5K and component 8K. It will be better to graph on Tableau. So, okay, let's close it here. Let's open the Tableau. And let's see what we have. So here, remind me tomorrow, it's in the older version. And okay, exponential distribution on Tableau. We have two sheets, so we need to tell Tableau which one we are using. Tableau. Okay. So first, let's go on this chart here, the chart of exponential distribution. So it is exactly, and then the hours. Hours is not a variable. Hours is a dimension. So convert to dimension. And then number of hours. So this is our distribution. However, it is a distribution of components A and B together. So here the exponential distribution. But we want to filter or we want to compare both. So let's go and show me component. Here it's much better, but it's a little bit confusing. So let's go on component, on color. Now we have component A and B, or component 5K and component 8K. And then let me move around here. So we have here component A will be decreasing much faster than component B. Okay, and let's add the filter for components. And then let's show filter. Now we can go only one or both, only one or both. Or none here. And I want the same filter to the next one, that is cumulative. So apply to worksheets, all using related data source. So the second one, the same, hours, component, but now the cumulative. And here, cumulative distribution. Whoops. Component, color. See how the component B is much faster. So probability of failure much faster than component B of the 8K. That is okay. And then if we have money, here how much this component costs, we can work with a much better depreciation expense, for instance, or save money to replace it, and so on. So it's much better. And here we can also show the future, but we will combine in a dashboard. So here, combined dashboard. And let's add a title, show title, and exponential distribution, cumulative. Now I can move myself over here. And when we, so component A and B, I want only the component of 8K, I go here. Only the 5K, I go here, or all, I go here. And then if I want this combined dashboard, if I want to change the name, just delete here and type anything here. You will have it. Or here, I want to center it. So, very easy to do. Or we can also hide this component here. Whoops. So we can work on the axis here. So, whoops. Let's come back here. Let's go on title again. And here we have a situation where we need, see that we have a row here. So standard, fit width, now it's better. And here the same problem. Standard, fit width, we have the same Problem here. Oh, you cannot change here. You can change this axis here, but this axis is much harder because it is the name of our variable. Okay, guys, so this is our dashboard for our uh, exponential distribution. And this Tableau file is also on video description. Okay, guys, have a very nice day and God bless you.